Yes, I mean, a quick introduction about the company. Chromalox is an American-based company, and we are manufacturing this heaters and heat tracing cables for like 103 years now. It's quite a old company, and we have been manufacturing these products for quite a long time. So that is, I mean, if a company has to sustain for such a long time, obviously you need to have the right product as well as the quality product, which helps the company to survive for such a long period. That's the history of the company. So we have an office in Pittsburgh. That is the head office for us, and we have spread around the globe. We have many offices in Asia, in Europe, and North of America. So and this office, what we have in Dubai, is basically a sales office. And for heat tracing, we do the engineering from an office in India. We have an office in New Delhi where the heat tracing design is being done. Yeah, so that's about the company now. Now, what I do is that I'll just pass it on to Yogesh. So he will start the installation, the procedures. Before Yogesh start that, if I can get a very quick introduction from your team, so that you will understand, the target audience, so that he can rephrase the statements according to the target audience. So if you can introduce yourself, it will be good.
So my name is Senthil Nathan. I am the manager of projects in charge for the overall MEW project. And with me, Mr. Ajit is the project manager for Doha. And Mr. Bhaskar is the project manager for our Sabia project. Right. And we have our friend Jagadish, he is a electrical design engineer, and Manikantan, our QAQC engineer. So only 4 people is available here, only for the technical discussion.
Right. Okay. But here we are showing more of installation. So obviously there is no technicians which is available from your team, right? Who is going to do the on-field installation?
Yes.
Is there any technicians who is there in the team where?
No, technician not there. Our supervisors and engineers are there. They will manage, no problem.
Okay, perfect. All right, fine. So what I'll do is that now I'll start the presentation. I'll be sharing my screen. So once you see my screen, just let me know. Then Yogesh will take it out from there.
Yes, enlarge it, please. Make it full screen.
Is it better now?
If you can, I think it is a full screen option, right?
That's the full screen. That's the maximum.
No problem.
All right, yeah. Yogesh.
Good afternoon, gentlemen. I hope I am audible to you all.
Yes.
Okay, fine. So let me begin with the agenda, what we are going to cover today. What are the things we are going to discuss? So the first point we will be discussing about some general notes or the key notes which has to be taken care prior to the commencement of the installation, and also there are some key points which need to be taken care of during the installation. So that will be the first topic we will be covering. Second topic, we will touch up that how to study the isometrics prepared for the heat tracing installation, is how to use it for the installation purpose. What are the important credentials we have to look into that we will study. Then we will look into the tools required to carry out this job. After that, we will be understanding how the heating cable is constructed, or I can say how what are the sub-components or the sub-parts of the heating cable that we will look into. I have one sample piece available with us, so that will be shown to you. Sorry?
1 minute. என்னோட மானிட்டர் இருக்குறோம் அது பெருசா இருக்கும் இங்க வச்சிட்டு அது கனெக்ட் பண்ணிட்டோம். Okay, proceed please.
Okay. The next topic will be installation of the heating cable. How to install the heating cable on the linear pipelines, supports, flanges, valves. So such kind of topics will be covered. Point number 6, we will cover the installation of the components like junction boxes, thermostats, and how to make the terminations of the heating cable in those equipments. We will look into that. And the last section will be the testing of the heating cable. how, in what sequence we have to do that, and how to keep or how to maintain our records, that we will touch on. So this will be the agenda we will be discussing today. Next. Okay, key notes and installation preparation. The first and most important part, that securing the material once received at the site. Once you have the heating cable and the other components in your custody at the site, you have to store it at very clean and dry area. Intention is that these cables, heating cables, are prone to moisture absorption. So there is a high possibility in the humid environment, the cable could absorb the moisture, and it will lead to the low Megger values. So it is very much mandatory to store the material in clean and dry place. This is the first important point. Second, when you receive the cable and other items, you have to ensure that there is no mechanical damage or abuse on the received material. You have to physically check. Sorry, is it echo?
1 minute. There is some. மேல இருக்கு பாரு, HDMI மேல இருக்கு பாரு, HDMI 3 டிவிக்கு மேல. Yes, please.
Okay. So once you receive the cable and other accessories, all the items need to be verified physically for any kind of mechanical damage or abuse. It is not only when you receive it, but also before you take it for the actual installation. Before that also, those items need to be physically or visually inspected to ensure there is no damage on the item supplied. Third important point, before you start with the installation of any of the items, heat tracing cable or accessories, you have to ensure that the surface, right now in this case it is a piping, and I believe there could be some vessels also, probably. You have to ensure all these items are complete in all the aspect, in all mechanical aspect. I mean to say the painting, hydro test, any kind of mechanical fitting, welding, all these activities has to be completed 100%. Once you install the heating cable and the components on the pipeline or on the surface, no mechanical activities are allowed on those surfaces, because there is a high possibility, like means there are many cases we have seen after installation of heating cables, customer sometimes they end up in like doing the final touch up on the nut bolt tightening where the gaskets are getting replaced, or some areas where they are having some leftover mechanical work and they try to cover it at a later stage, which is not allowed. Problem is that during all these activities, there is a high possibility the cable could get damaged, because these cables are whatever the insulation thickness on the cable, it is not so good enough to handle this mechanical abuse. So those cables can get damaged. So this proper care has to be taken. Then you have to ensure before you start the job, you have to have the right material, right tools as per your bill of material and isometrics. When I'm saying bill of material, there are two bill of materials which you have to look into. One is a project bill of material, which is covering all your items from required for your entire job. And there is an independent bill of material given in the isometric required for each heat tracing circuit. When I'll get into the isometric study, I will discuss about that bill of material also. So when you start for any circuit installation, you have to review that bill of material and you have to ensure that those items are there in your custody. The last item on this slide is this is kind of a chart you have to prepare. Once you receive the cables, it will be in a different drums, means you will be having multiple cable drums in your custody. So you have to prepare a chart against those drums, that which drum will be utilized for which circuit. You have to decide on that well in advance, so that when you start with the actual installation, you will be using the right drum for the right circuit installation. This will help you to minimize the wastage, and also there will be a less chance that your circuit length will be shorter than actual requirement. So this chart preparation, that which drum will go for which circuit, has to be done once you receive the drums at the site. Next slide.
This you have to decide, or you will decide?
This has to be decided in the field. Once you receive the drum.
Given the isometric, each pipeline length and other thing, how the cable is going to be supplied in what length, it is known to you only. Whether you cannot decide on this?
No, actually these drum lengths are finalized in factory, so we don't get that information. What we can do, once you receive the drums at the site, if somebody from the site give us the details of the drums, like drum number and the cable length on that drum, it is mentioned on that. There is a label on that. If you give this information to us, we can work out this chart for you. That is not a problem. We can help you on that.
Okay.
Yeah. Next is identifying the right piping configuration, or I can say identifying the right pipe where we are going to do the heat tracing installation. You will be having the isometrics in your hand when you will start the installation job. So it is very much important to correlate with the line number, the pipe size, and the general orientation of the pipeline. Sometimes actual installation of the piping is not matching with isometrics. Always there are some field modifications which happen, and then it leads to some kind of confusion whether are we doing the heat tracing installation on the right pipeline or not. That has to be thoroughly verified. If any ambiguity is found, then it's better to consult with a design team first, whether we can still continue with the same circuit installation or the same cable length installation on the modified pipeline. That certain, I can say the confirmation should be taken from the design team to avoid any kind of a mismatch on the piping length and the heating cable length. So identifying and studying the pipeline thoroughly is also important. Once the pipeline is identified, you have to decide, or rather based on the isometrics, you have to mark the location of the junction box, where the junction box will be installed, and where the end seal or the end cap of the heating cable will be kept. I will show you in the drawing where the junction boxes are shown and where the end seals are shown, but physically you have to verify in the field which are those locations with reference to your coordinates, and you have to mark it with some markers or some chalk to freeze the locations. Once the locations are marked, and before you start laying the cable, you have to clean the pipe surface or whatever the surface you are going to install the heating cable, you have to clean it thoroughly. There should not be any accumulation of the dust or grease or any dirt on the pipeline. The pipe should be cleaned thoroughly. Next step will be you have to choose the, as I said, you have to prepare.
Mechanical cleaning, wire brushing is sufficient, right?
Sorry?
Cleaning means the surface of pipeline cleaning means by wire brushing it is cleaning is that is sufficient, right?
You can use some cloth. It can be pipeline can be cleaned with a cloth. Intention is that when you put the heating cable, if it is having some dust on the pipeline, the glass tape or the aluminum tape which you use to fix the cable on the pipeline, it will not hold properly. It will come out easily.
Okay.
So just to have the proper adhesion or the strong adhesion on the pipeline, this dust has to be removed.
Okay.
Next step, as we discussed, like we have to prepare the drum chart, the cable drum chart. Based on that, you have to select the right cable drum for the circuit for which you are going to install the heating cable. So that selection has to be done in a proper manner. Once you select the drum, you have to take a note of that drum number. On drum number, you can have, there is a cable length is mentioned, the total cable length is mentioned. And also on the cable, there is a printing for the every meter length, the printing is done. So you have to note down the starting meter length. And also once you complete the circuit installation, wherever you cut the cable, you have to take a note of the end cable length. So that will give you the total length of the cable installed on the given circuit. So these three parameters you have to record when you start with the installation: drum number, drum length, starting length marked on the cable. Next point.
This point is clear because this is a very critical activity which has to be done in the site. So is this particular point is clear to everyone?
Yeah, clear.
Yes.
All right, fine.
Okay. Before you unroll the cable from the drum, you have to do the measure. It is normally advisable that 500 volt DC measure is good enough, but I recommend to do it for 1000 volt DC, and measure value should be more than 20 mega ohm to use that cable further for any kind of installation.
So this will be done when the cable is there?
On the roll, on the roll.
Okay, right.
So before unrolling it, rather when the drum is there in their storage area, they should do the measure of all the drums and they should prepare one report for that.
Right.
Okay, the next. I have highlighted it in red because it is critical task. So that's the reason it is highlighted in red.
Yeah, this, the cable testing.
Yeah.
Yeah, this one core and the protecting armor, right?
Yeah, it's a good thing. I guess I have not covered that. Yes, good that you have asked. The measure has to be done between the two bus wires of the cable and the bread. I will show that to you now. I guess the video is also there, right?
Because you can see as well. The video, you can see the video.
No, your screen is small because the presentation mode is on.
Okay, fine. Right, so we'll go to the video. You can see now?
No, my friend.
You have to on.
Yeah, now go
It is
to.
difficult to. Okay, go to the presentation, Pranab. Again, let it be. I guess it will be difficult to demonstrate.
No,
this.
probably like you can bring it closer to the.
There is one construction of the heating cable is there. I will demonstrate in that.
Okay, fine. So you don't have to show it in the video.
No. Yeah, in this it will be difficult.
Okay, all right. No problem. So you want
that cable construction slide.
Okay, fine.
This one. Yeah. Okay, this is the cable construction slide where you can see the outer jacket is there. Then there is a copper braid is there, tin copper braid. Then there is an inner insulation jacket is there, and below that there is a conductive matrix, and the two bus wires are there. So you have to do the measure, means the two bus wires you can connect together on a one probe, one crocodile probe, and another crocodile probe you can put on the braid. And between these two items you have to do the measure. So between two bus wires and the braid. Not between the, you should not be doing measure between the two bus wires. Those are anyway acting as a short because there is a conductive matrix in between them. I hope I'm clear to you.
So you have to take plus in the conductor and minus we are putting in the buried, correct?
The two bus wires are as good as short circuit, means there is a conductive medium between the two bus wires. So there is no point in doing the measure between the two bus wires. You have to do measure between the bus wire and the braid.
Yeah, that's why I asked. Okay.
Yes. So now, I'll take it off from the presentation mode and I'll show the video. Now, so if you look into this, I'll come closer to the camera. This braid will be removed. This braid will be taken off from the conductor. All right. So between the conductor and the outer jacket, this is braiding. This is the braiding. So for these two, the measure has to be done. And how this will be ripped off or how it will be separated, we will be showing in, you will be demonstrating that. Yeah?
Yeah.
All right. We'll continue with the presentation.
Okay. Before starting with putting the cable on the pipeline, we have to understand the obstacles which are coming in between our cable installation route. There is a high possibility the pipe could be moving through the complex structure area. It could be having some nearby mounted instruments, some supports, or some kind of obstacles will be there, which could have a problem in our cable installation. So it is better to put the drum at one of the end, either at the end seal end or at the junction box end, and unroll that complete circuit length throughout the pipe, and we have to trace the route of the cable along with the pipeline. That will help to avoid any kind of obstruction, means we can avoid any kind of obstruction which will come in between the cable installation on the pipe surface. Is this point clear to you? Because it is a little bit tricky to explain because okay, I have to maybe demonstrate something.
This wire cannot be pulled like a normal cable pulling. We cannot pull like that, right?
Sorry?
Is it like normal
Normal cable
cable
pulling. Like that, we cannot uncoil and directly pull this cable on the pipe rack, on the pipe and other thing. It cannot be done the same normal like a normal cable, right?
These cables, normal cables, I believe you use some rolls to pull the cable, right? So
Yes.
those kind of rolls are not required, but yes, some jack will be required where you have to put the cable drum.
Okay.
And you have to pull the cable along the pipeline. On the pipeline on which you are going to lay the cable or stick the cable, you have to pull the cable along with that. As I said, there is a high possibility since it could be going to some complex area where there could be a nearby structure. Because once you start fixing the cable, sometime it happens once you start fixing the cable, you might notice, okay, there is some obstruction because of which the cable is unable to reach to the pipe. It is getting obstructed by some support or some kind of intermediate media. So finding the right way to the cable is very much important before you start fixing the cable.
Okay.
Is this point clear?
Yes.
If you want, I can explain it in maybe some another way by just taking some tools to explain it.
Yeah.
I will try to do that on a video mode.
on the video mode? Yes.
I'm just taking the example of this pen. Consider this pen as a pipeline, as a straight pipeline. While fixing the cable on the pipe, I have to ensure there are no nearby structures which are touching the pipeline or in a close vicinity of the pipeline. Because once I pull the cable or once I start fixing the cable, and if there is some obstacle is there, then I might have to either remove the cable again to avoid that obstacle, or I have to do the splicing, which is very inconvenient way to do that. So it's better to find a proper route of the heating cable along with the pipeline in the first go itself. Is that clear?
I'm going to say you want to start from one end to reach other end.
Yes, we have.
From the pipeline, we cannot go in between pipeline to start the other side. You have to start one end, you have to continue to until other end with the same drum without any obstructions.
Yes, you unroll the cable from junction box to the end seal. Whatever 100-meter length, you remove that much cable from the drum and keep it loose along with the pipeline. So you will be knowing that it is not getting obstructed anywhere.
This is like normal cable, we can pull both sides. Normal cable drum keeps center, we can pull both sides. But this heat tracing, we have to go one end to other end.
Yes.
So, but the issue is, what about the position in the pipeline? There is some recommendation for the position in the pipeline, right?
Yes.
Yes, the position generally it should be on the lower side of the pipe. That is the position of the cable where it has to be installed.
That
for the two-run 5-7 position, correct? 5 o'clock and 7 o'clock position we have to maintain, correct? For the two-run.
Yes, it is recommended that cable should be always on the bottom side of the pipeline, maximum bottom side. So 5 and 7 are the most ideal locations. But
5 and 7 is for the double run.
Yes, for double. Even single run also, you keep it at 5 o'clock.
Okay.
Yeah. The reason being, there are two. Yeah.
Is there a relation with the process? If the process is liquid and gas, whether the position is going to be changed upon the process?
There are two things. First thing, the cable is well protected when it goes below the pipe diameter. Means anything falling from the top, any mechanical abuse, it is always protected when it is on the below surface of the pipeline. This is the first point. Second point, in the liquid media, when the pipe is like you drain out or when you clear up the pipeline, there is a high possibility that some portion of the material tend to remain at the bottom of the pipeline. So it is always better the heat should be transferred from the bottom of the pipeline.
So my question is, most of the time, the liquid is always floating on the bottom of the pipeline. So if the gas media is supposed to be on the top of the pipeline, that way whether we need to change the position of the cable, depends on the medium.
I guess in this case we are not heating any gas, we are heating the liquid.
No,
we are maintaining the.
We want this Doha where we are using the tracer line, it's for the gas line. Okay, in Sabia we are using for HFO. That is why he is concerned.
Okay, those gas lines are the impulse tubes or the pipelines?
Pipeline, it's a pipeline, 42-inch pipeline.
Okay, so in the gas condition, yes, obvious. Depending on the media, the orientation changes. The liquid tends to settle at the bottom of the pipeline, and the gas tends to be on the upper surface of the pipeline. So there, definitely, as you said, the orientation can be changed.
So we recommended for the gas, we recommended to keep on top of the pipe, correct?
Yes.
Tracing.
Yes. What is the pipe size you have said? 42 inch. And okay, I have to check for the trace ratio, like how many cables are installed on a pipeline, whether it is a single run or multiple run.
After your isometric, you showed it's a 3-layer.
It's a 3-run.
Yeah.
Okay, it is better to keep on the above half, on the top half of the pipeline, the cable should be installed in that case.
All three at the top side, eh?
Yes.
Like 90 degree, 190 and 360 degree.
What we can do, sir, we can prepare one schematic for that, for these orientations and the cross-sectional view drawing, and we can share with you.
Okay. So Q and level, that is recommended? Q o'clock, 11 o'clock position? Or?
No. He will send. Actually, what he said.
We will send you the correct drawings suitable for your application.
They said they will prepare, correct?
Yeah, they will.
Because as per their general typical installation is showing both.
See now, okay, we have one more query. Now for Sabaya, you know our Sabaya plant, we are going to replace the existing steam tracing. The existing steam tracing is at the 7 o'clock and 5 o'clock position. You know, unless until our heat tracing system commissioned, we cannot isolate the steam tracing and we cannot avoid this steam tracing because the line is already having a fuel supply to the power plant. We cannot suddenly stop this one and we can change it. Because since the existing steam tracing also in 5 o'clock and 7 o'clock, your catalog recommendation shows this tape also has to be fixed in 5 o'clock and 7 o'clock. How we will proceed about this issue?
Okay, the first of all, I want to understand what is the maximum exposure temperature our cables are going to face, because the lines where the steam installation is there, our SRME cables are only suitable for the installation in such kind of environment. Other cables, SRP or SRL, if they are there, then definitely we cannot install those heating cables along with the steam trace pipelines.
We are getting only SRME here.
Sure.
Yeah, all cables are.
Okay, then it is fine. Then it is need not to be necessary exactly the 5 and 7. The 30-degree displacement has to be maintained between the existing installation and the new installation. So
No,
the 30-degree.
Since you recommended for the liquid service, better keep this tracing cable at the bottom side. Already the bottom side tracer is there. That is why our main concern.
Yeah, so that's the reason I said you can go for 8 o'clock and 4 o'clock in that case.
Okay.
But sir, I suggest or request if you can share those line details where you are having this steam tracing installed. We can make specific drawings for those installation where the angle is changing, where the angle is 8 o'clock, 4 o'clock.
We will send you by tomorrow.
Okay, so steam tracing.
Because what happened, last week we had one meeting with MEW and Penspan, wherein we have showed your catalog. In your catalog is specifically mentioned fixing tape at 5 o'clock and 7 o'clock position. Then they raised the concern already 5 o'clock, 7 o'clock steam tracing is there. How then we will fix this one? And we cannot allow to shut down the steam tracing system unless your electrical tracing is commissioned. That is why the question raised.
But sir, I have a question on that. Anyway, to install the new heating cable, you will be removing the insulation. So are you going to do that job in a segmental manner, or you will be?
See, now what we have proposed to MEW, the segment wise, we will install the heat tracing tape. We will keeping the same old insulation, again wrap it up and we will complete it. Once all our electrical tracing system completed in complete manner, then once our tracing system energized, we check it is function properly. Then then we will isolate the electrical tracing. Segment we will cut the electrical steam tracing pipe and insulate with the new insulation.
So it means that you are not going to remove the existing steam, rather you just cut and and those steam tubes will be retained within the insulation. Is that right?
No. That option also we have given to MEW, because in future, suppose if you want to take the maintenance for electrical heat tracing system, that time they will not have any heat tracing system available for the pipeline. So we given the option, okay, in future if you want to take maintenance, if electrical system is having some major issues and other thing, you can shut down electrical system and to switch over to the steam tracing system. But still now they are not decided on this aspect. Still they are thinking. For that we have one more presentation.
So the issue is now the climate is going to keep it cold. So it is mandatory to keep one system, either steam tracing or electrical tracing. That is the concern now.
Right.
Because power plant where it is located, the winter and all, sometime it go to 0 degree, the atmosphere, minus sometime, a steam case 2 years before it is gone -2, -3 also, that's why.
Okay. But I can say if you talk about the maintenance part, technically speaking, or the whatever experience I have so far, electrical heat tracing system is as good as a maintenance-free system. Means once you install it, you forget it for like the life of 20 years or 25 years. That's how the system works. I've seen the systems working for such a long time. Rather, the steam tracing will have a more frequent maintenance requirement.
Yes.
That is the observation. Yeah.
Okay.
Okay, fine. We'll go back to presentation.
Right. So where are we here?
Yes. Yeah, this slide. This one, which is. Okay. Second point. Once you start installing the heating cable on the pipeline, don't cut it until you complete that circuit installation completely. It is advisable. Yeah.
Okay.
Then while installing heating cable, you have to ensure, because since you are going to unroll the cable for the complete whatever the circuit length, which could be like 100 meter or it could be more also. So there is a possibility that cable could be lying on the floor or on the gravel or on the supports. So we have to ensure that any kind of a mechanical abuse or damage should not happen to the cable. So the cable has to be protected in all possible way every time. Next. Okay. Once the heating cable is installed, there is a one step, sequence will be there that you have to measure it again. And after the measuring, once your QC inspection is completed, you have to insulate it immediately. So that window is recommended like 1 day. Once you install the heating cable, you should complete the measure of that cable, and the further insulation activity should start within 1 day.
Maximum, what is the duration we can keep it exposed?
Maximum maybe another 2-3 days are okay, but practically, or means if I say to have a proper install, because issue is with the glass tapes. The glass tapes what we install on the tracing cable to fix it. If you keep it open for 2-3 days, they tend to lose their adhesiveness. That is a high possibility. So it is advisable to do it within 1 day, or maximum 2 days. Worst scenario.
Okay.
There are inspection procedures are there, no? After laying cable, you have to do ER testing, inspection, and then again insulation test. After insulation, again one more inspection. The procedure will take time.
Yeah, yes, that sequence I have explained in the last slide of this presentation, that how often or how in what sequence you have to do the measure and inspection.
3 days is very less time. 2 days, 3 days exposure of this cable and tape is very, very less time.
So, sorry, I didn't get it.
The duration what you said is too low, that's why.
1 or 2 days are very short. Is that what you are saying?
Yes, the length of drum and the insulation work will take time, right?
No, once you install the heating cable, say for 100 meter of the pipeline, once you install the heating cable, you have to call the quality inspector for the inspection of the installation. If they accept it, you do the measure in front of them. And then it is recommended like within 1 day, you should start with the insulation job on top of that. You start putting the whatever the blankets or the pipe sections on the pipeline to cover it.
Anyway, actually speaking, the dressing in the pipeline itself takes at least 1 or 2 days. Then the tape will be minimum exposure is 2 days. Then we go for insulation. They will take another 2 to 3 days.
No, sir, it won't take that much time. If you are talking about a linear pipe length of 100 meter, where putting say 100 meter of the cable, it can be completed within a span of 4 to 5 hours.
Okay, anyway.
Yeah. The next point is about openings of the cladding. Once you do the insulation on the heat trace pipelines, then you are going to cover it with the metal jackets which are cladding. So you have to ensure all the claddings are sealed properly. There should not be any possibility or opening is there where the moisture ingress could happen. That will derate the quality of the insulation, and also wherever the heating cables are getting spliced or termination is happening, there is a possibility it will absorb some moisture. So the insulation contractor should be advised that all the openings should be sealed thoroughly, and the cladding has to be done in a waterproofing manner, or the whatever the like during the rain or any kind of water splashing is happening, the construction is made in a such a way that water just simply drifts away. It will not stay on the cladding. The insulation contractor should be also advised to use the drill bit with a shorter length than the insulation thickness. If the drill bit, this drill bit length I am talking, when they are going to screw it on the cladding, they have to do some kind of a drilling on the cladding to screw it. So that drill bit length should be less than the insulation thickness, otherwise it will completely penetrate the insulation and it could damage the heating cable. And this kind of incidences have happened in past many times, and it lead to so much of blunder that finding such locations are very difficult. Once you install the complete system, it will be very difficult for you to find out where the cable has got punctured. So this precaution has to be taken.
40. Then the screw will not be 40 mm. Screw will be maximum 5 mm or 6 mm.
What they can do on the drill bit, they can put some kind of the tape, marking tape, just to understand that they should not insert their drill bit more than that length. So they can do some kind of a marking by putting some kind of tape, insulation tape or something.
Sure, okay.
Okay. The heating cable ends always need to be covered with some kind of a cap to avoid any kind of moisture ingress. When you are done with the installation, then there is a high possibility you could call the inspector on the next day, or it will take some time to insulate also. So you have to cover those ends with proper some kind of a sealing, not sealing material. You have to put some caps on those cable ends to avoid any moisture ingress. Next.
Right, okay.
Yeah.
So, I mean, till now, is there any queries you have from your side regarding the preparation? Because then we'll move on to the isometric drawings.
So actually the conclusion, you are going to be given the exact position depends on the medium you are going to provide, correct? That was the conclusion. Okay.
Yes, and we will provide you the suitable drawings for those installations, and we need some inputs from you to know the steam tracing part.
Steam tracing location, correct? That's what you need from us.
Yes, yes, yes.
As well as the drum actual length you require from us, correct? To prepare the schedule.
Sorry,
the actual length of the drum,
okay,
they have to provide us from the site.
Yeah, once they receive in the field, they have to give us the drum number and the length. Then we can make the circuit allocation to each drum length. We can do that.
What you require from us? The position of the heat tracing, steam tracing, as well as the actual drum length with the number. That's what you require from us, correct?
Okay.
Yes.
Yeah.
And also how to design that run, how many runs are required for pipeline? That one, depending on the size.
No, this point is not clear. What is this?
Now the number of runs you already mentioned the isometric drawing, correct?
Yeah, it is there in the drawings. That I will explain now.
Yeah.
Okay, I guess we can go to the isometrics now.
Yeah, it is certain.
No, it is on the presentation separate.
Okay, right.
That hyperlink may not be working there.
Fine. So which part do you want me to zoom now?
let it be right now like this. I will just scroll it. Okay, this is the first page of the isometric. I have just taken it for from one sample from your project. It is for circuit number 101. Sorry, I don't have the scheme to display over here. The scheme is like the power supply is coming from panel to local switch, and from local switch it is going to field junction box, and from field junction box it is getting distributed to 3 local, or I can say the power junction boxes, which are directly mounted on the pipeline.
This one, we are unable to see this.
Okay, I will do one thing.
I mean, is it too small, or you are not able to see the screen?
No, I have not explained anything from the screen. Okay, but I'll do one thing. You can go to the next page, just zoom out. Zoom out, go to page number 3 or 4 something there I have seen. Next. Okay, this one. You zoom in this one.
This one?
This one. Yes. Okay. I don't have the scheme drawing, but from the isometric I will explain the power distribution scheme. That
now, this screen is visible to you, right? You can read what is written in that, correct?
No, can you hold on? I will share the presentation where I have the power distribution scheme. You can go through.
Wait, 1 minute.
Okay.
So I will share the screen. Now, when you see the isometric drawing on the screen, just let us know so that you guys can start.
This is what you are looking for.
Can you see the screen now?
Hello.
Sharing sharing.
Okay, you are sharing a screen. Okay.
Now this is what he is looking for, the power distribution scheme, right?
Just a second.
Just, yeah, you don't see that.
Isolation. Yeah, but again it is the local, I can say the PJBs are missing.
No, it is there, 1 minute. To see this one.
Okay, fine, this is fine, this is perfect.
This is the first one, this is the second one.
Correct. Yes, this is the one what I was talking about. So the first you will be having the local switch. Okay, we can be on the second slide only.
Okay.
From the distribution board, power supply will come to the local switch. From local switch, it will go to the MJB. This will be 3-phase power supply. And from MJB, it will be going to individual PJBs with a single phase supply, RYB. So I believe the scheme is clear, pretty much clear now.
Okay.
Okay, we'll go back to the isometrics.
So, yeah, I will take the control of the screen now.
Okay.
Okay, now this is not required. We'll go to the page 1.
Page 1.
Where we have to. Okay, since the scheme is clear to you now, I can now elaborate. Just zoom out a little bit. Should I take? I guess I have to say. All right. Okay, I have highlighted some areas with a yellow marker to understand that these are the important factors or the items you should look into before you start the installation. The first one which I have highlighted is the line number, second one is isometric. So it is very much important to identify the correct line for the circuit installation. There should not be any mismatch. Means whatever the circuit number or the tracer number is given, that should go with a dedicated isometric or the line number only. There should not be any jumbling or confusion between that. So this is first thing. Again, even though the line number is matching, we have to ensure the associated pipe size is also matching. Right now here it is 4 inch, so we have to ensure that 4-inch pipeline is there. Then in this particular the bill of material, or I can say the table, the 3 different circuits are 3 different single phase circuits are shown: 101A, 101B, and 101C. But all these 101, three single phase circuits are getting fed from the 101 PJB, FJB and the local switch. So there is one 3-phase power supply coming to all these 3 single phase PJBs. Then you have to check what type of the heating cable is required for these particular circuits. So type of the heating cable is clearly mentioned. So you have to ensure that you will take the correct cable drum for this job. Then you have to check what is the pipe length. You have to check physically that okay, you are having the exact. If there is then that impact. But if there is a drastic change, for example, if the pipe length is changing from instead of 103, it is getting changed to 150 or something, then definitely that is a point of concern and need to be discussed with the engineering team before the installation commencement. Then you have, the next column is the tracer per pipe. That is where you decide how many runs of cables will be installed on a linear pipeline. Right now, here it is written 1. So only single run of the cable will pass on a linear pipeline. If it is 2, then you have to put 2 numbers or 2 runs of the cable on a linear pipeline. If it is in a fraction, say if it is a 1.5, then you have to multiply 1 meter by the fraction of 1.5. That much length of the cable is required. For example, if the 10 meter pipe length is there, then you have to install 15 meter of the heating cable on that pipe length. So that's how the trace ratio or the tracer per pipe column works. Then you have to check what is the valve tracer per valve, that what quantity of the heating cable should be installed on the valves. So right now, if here it is mentioned as a 1.1 meter, then that much cable length is required to be installed on the valve. Here, very important point you have to take a note of. This 1.1 meter is for the valve loop, but also whatever is the valve length. For example, valve length is say 0.5 meter, half a meter. Then that half a meter plus 1.1 meter cable you have to install. Total 1.6 meter of the cable need to be installed on the valve. I will repeat this point again. You have to install 1.1 meter of the cable loop. Along with that, you have to add the valve length also. Valve length, maybe if it is 0.5 meter, then 1.1 plus 0.5 meter you have to add together, and you have to install 1.6 meter of the cable on the valve. Similar thing goes for the flange also and for the support also.
No, now you have told, for example, say a pipe length is 10 meter. If you want to fix 11 meter, you have to fix. Means how we will fix it? Zigzag we will fix. How we will accommodate the 1 meter extra cable on the pipe?
Yes, it is called as a spiral bound installation or the zigzag installation. I have covered that installation topic in the upcoming slides. Right now, I'm just explaining that what are the important factors you have to look into the isometrics.
Okay, so if the heating is depend upon the length of the cable, right?
Heating, sorry?
Why, for example, if the pipe length is 10 meter, you are saying it will be cable, sometime it will be 11 meter. Why it will be 11 meter instead of 10 meter? What is the reason?
Okay, so okay, that question goes to the design part. The reason being, we calculate the heat loss of the pipeline in a per meter length. For example, if the pipeline heat loss is say 30 watt per meter, then we have to give the cable equivalent to the 30 watt per meter. If we are having cable equivalent to say only 20 watt per meter, then to have that another 10 watt extra, I have to give only some 0.3 meter as extra length on the pipeline. So that leads to the fractional values. So your example of say 10 meter, for 10 meter if I need 100 watt, for the 10 meter, if I have to give 110 watt, but my cable is capable of giving only say 110 watt in the 11 meter length, then I have to put the 11 meter length into the 10 meter stretch.
Okay.
Yeah, I hope I'm clear on that explanation.
Yes.
Okay, fine. So this is about the items which we have to look into before we start with the installation. The next thing will be the bill of material. As I said earlier, there are 2 bill of materials. One is your project bill of material. Second is this bill of material, which is a part of isometric, and I can say which is a part of this particular circuit. Here you can see the first item is a 3-phase junction box, which is FJB that will be required. Then item number 3, which is a 3 numbers of single phase junction boxes, come thermostat are required. Then we need 3 end seals. And again, 3 end seals are again mentioned like one set is equal to 5 pieces, and they are asking to consider the 3 sets. So I believe the 15 end seals are required.
Now, one more question. This pipeline is having a drain and a vent pipe. This also has to be traced, right? Like the valve, how we are tracing, this vent and drain also has to be traced, right?
If it is shown in the isometric, yes, it has to be traced. Otherwise, ideally, it has to be traced. It is specifically the drain, yes, it has to be traced. But if we talk about vent, it is a call of the customer. Sometimes they do go with the insulation also.
Okay, okay.
But whatever covered in the drawing has to be traced. If these drain and vents are shown in the drawing, then definitely it's already covered.
Okay. All the pipeline, yes. All pipeline.
Yeah. The pipe straps are to hold the equipments on the pipe support, on the pipeline, which are like junction boxes, from thermostat, we have to fix it with the pipe strap. Then cable guides and some accessories are there. And finally, the most important part is the what type of the heating cable and what is the length. So when you select a drum, you have to ensure that SRME 10 cable with this much length is available, or else, since we are going to do this circuiting in 3 segments, there are A, B, C segments are there. For segment A, we need 120 meter of the cable. Segment B, we need around 125 meter or 126 meter of the cable. And segment C, we need around 100 and, okay, it is 122 meter of the cable. So at least these segments should be covered into that cable drum. So that kind of, it is a very simple mathematics we have to run through, and we have to prepare a chart. So we will have a right consumption of the heating cable. Next part, I am just touching on the isometrics, like how to. Is this visible to you clearly? Is it visible, or should I zoom in further?
Yeah, better to zoom in.
Okay, this is good enough?
Little bit.
Little bit more? Is fine?
Okay.
Okay. So once this line is identified, which is 4-inch OO fuel EIP, once you identify this line, you have to identify the location of this junction box, where exactly it is coming. So for that, we have to just in the field, the field supervisor has to compare this isometric with the actual piping installation. And based on that site survey and analysis, he has to decide where this junction box has to be mounted. Okay, that location marking has to be done. And then as per the earlier document, I have shown the tracer quantity per linear pipe length is 1. That means only one number of heating cable should run along with the pipeline. So that one number of the cable will run throughout the pipeline, and you have to follow the isometrics for the continuation thing. On the next page, you will find the further continuation of this drawing. Here you can see the cable is traveling all along this length. Then there is a loop in between. There are some 2 valves are there which are acting as a bypass loop or something, which also has to be heat-dressed, covering all those lengths. And I believe this is something, a vent, which you were asking for maybe probably. So covering that, the circuit is ending somewhere here. The end seal is somewhere here. So cable will get terminated finally here. So when you start installation, that cable length was 120 meter something. You have to unroll that cable of 120 meter throughout this length, and you have to identify that cable should pass properly through all the pipe structures. Here there is a possibility that cable could get entangled here. So before starting the fixing of the cable, someone has to check that cable will properly cover all these extension valves or extension branches. That routing has to be done thoroughly. Is this clear?
Yeah.
Okay. So the isometric part I will end up here. I will get into the actual installation manuals, drawings, and from there I will start. Tools required are very common and simple. You need a screwdriver, preferably the -1, knife, plier, and the scissor or some kind of a cutter to cut the bread or sometimes that conductive material. Construction of the heating cable I have already discussed, so I will skip this part. Okay, these are about the orientation and installation of the heating cable on the pipeline and various surfaces. So in the first drawing is applicable for the single run of the heating cable. You can see it is installed as good as between the 5 o'clock and the 4 o'clock, almost at the 45-degree angle. So similar kind of a cross-sectional drawing we can provide you for your different type of configurations. This is for the single run. Here in the second drawing, it is shown for the double run. If the truss ratio is 2, that means there are 2 runs of the heating cable per linear length of the pipeline. Then the arrangement is shown like this: 45-degree displacement from the horizontal surface. One more point you can note here: the distance between the glass tapes is approximately 12 inch or 1 feet or 30 centimeter. This you have to ensure that you should not reduce it, or I mean to say you should not keep the glass tapes too closer also or too away from each other also. This 1 feet distance has to be maintained. Fixing of the glass tape is a unique technique. Unfortunately, I don't have a sample glass tape available in the office to demonstrate, but I will tell you how to cut the glass tape in the field. Once you roll the glass tape over the heating cable on the pipeline, I'll go to the video part again. Is there any roll or something? Which roll? Something circular part. This cap. Sorry, I'm taking some wrong items for the demonstration, but just to explain, is it visible? Our video is visible?
No, you have to check it.
Yes. I made enlarge, no problem.
Oh yeah, fine. Yeah, you can stand and do it, right? It'll be clear.
Okay. Once you roll the glass tape around the pipeline, you have to rub the glass tape on the pipe surface itself. It will automatically break the glass tape over there. You don't have to cut it with a scissor or you don't have to pull it. It is a fiber glass tape. So just if you rub it on the pipe surface, it will get damaged over there and you can discontinue that. Right now I don't have a sample to demonstrate, but maybe if I get something, I will share the video. I'll prepare one video and I'll share with you that how to cut the glass tape. Okay, the third drawing, which is about the spiraling, what we discussed, that if you have to, if you want to install, say, for 11 meter of the heating cable in a 10 meter length, then you have to wrap it around. Okay, but here you should not be just coiling it around. You have to fix the 2 ends of the heating cable. If in the 10 meter length, you have to fix both the ends of the heating cable, and from the middle you have to start the spiraling. You should not be just like from the starting point. You should not go keep on doing the coiling. Because in future, if you want to do any kind of maintenance, then you have to remove the complete insulation. That is not advisable. So it is always recommended when you are doing spiraling, fix the 2 ends of the heating cable, and from the center you start wrapping it around on the pipeline. And for a longer length, I know it is difficult. So what you have to do, you have to do it in a segmental manner. If the 100 meter pipe length is there, you have to do it in the segmental manner of 10 meter each. Then it will be very easy for the installation purpose. Is this point clear?
Yes.
Okay. The fourth drawing is about how the cable should be routed on the elbows or the risers. The cable should always travel to the outer radius of the elbows. Wherever the outer bending is there, the cable should be passing through those areas only. That care has to be taken. Now coming to the flanges and valves. As I said earlier, there is a loop or the margin is given for the flanges and valves. So in our earlier example, 1.1 meter of the cable was supposed to be installed on the valve. So what I want to say, you have to consider 1.1 meter plus the length of the flange. If the length of the valve, if the length of the valve is 0.5 meter, add this 0.5 meter into 1.1 meter, it will be 1.6. So that much cable should be installed on the valve. For that also, you have to fix the two ends. You have to fix the two ends of the heating cable with a glass tape. You can see my cursor. You have to fix the cable here, and then you will be having a hanging U shape over there of the cable. And that U-shaped cable you should be wrapping around on the flange or on the valve. It will be good for the maintenance, future maintenance also, and it gives a better possible surface area to install the heating cable in the valve. Important point, the cable, you have to try to establish the maximum contact of the heating cable with all these structures. You should not be leaving any gaps or voids. But for that, you don't have to bend the cable harshly. You have to be a little gentle on that, but still try to cover the maximum surface. For the support, again, you have to make this kind of arrangement. It is called as the S arrangement. So whatever the margin is mentioned in the design sheet for the support, that much length plus support length, you have to make it as S or Z on the support structure. For equipments, this is the way. It is as good as what you do for the valves. Similar thing you can do for such kind of pressure gauges or any kind of level gauge equipments are there. This is the way it can be done. Junction boxes, T boxes, wherever you are putting it, don't forget to put half a meter of the maintenance loop. You can see at the bottom there are some zigzag fashion arrangements are made. Those are the maintenance loop. So you have to leave half a meter of the maintenance loop below each junction box or the T box.
This is in future if you want to cut the cable, cut and adjust, right?
Yes, correct. In case if any maintenance work is there, you can use this additional length. Now I'm getting into the termination part, that how to terminate the heating cables into the junction boxes. Right now I have taken the example of the single entry junction box, and then I have some couple of videos which will demonstrate the heating cable termination into multiple entry junction boxes. So the key components of your single entry junction box is your junction box. Then you are having this compression fitting. Then you are having a lock nut. Then you are having a silicone termination boot, pipe standoff, RTV sealant, O-ring. These are the two grommets you will find with our connection kits. You have to use the black one, which is for the self-regulating cable. Orange one or the red one is not required. That is for the constant wattage cable. The first item you have to fix on the pipeline is the standoff support. Once you fix the standoff support on the pipeline with this pipe strap, anyway, before that you have to pull the cable through it, and you have to ensure that above this grommet you will have the 8" of the clearance of the heating cable. In this 8" of the clearance of the heating cable, you have to leave 1 inch, and you have to cut the outer insulation through the knife, and you have to free the cable from, you have to free the bread from it. Once you are exposed to the bread.
Repeat the number again. It is 8" of the cable should be terminated on top of the junction.
8" from this grommet. 8" from this grommet. Then leave 1 inch. You will have a 7" from here to remove the insulation.
Now, 1 minute. Now, you have given the cable length for each pipeline, right?
Yeah.
When you have given the pipe length, this all 800 mm or 8" you have considered in the length, or in addition to the length what you have given, you have to add this one?
No, these termination loops are already considered into our design.
Okay.
Yeah.
Yes, just during the installation, you have to ensure that that much around 8" of cable is being left on top of the pipe.
Yeah. I'll do one thing. I'll run through video first. If required, then I'll get into the slide because both things are same.
Okay.
I'll run through video.
Maximize the video.
This video covers the wire preparation of self-regulating cables for use with the Chromalox U series.
You can hear the voice also, right?
Before beginning the
Yes,
project, connect all power and make sure the installation is grounded in accordance with the National Electrical Code. Also, be sure to turn off the power before removing the end cap. Adequate controls and safety devices should always be installed with any electrical heating equipment. Now let's get started. Insert the heating cable through the pipe standoff and grommet as shown. 8 inches of cable should extend past the grommet. Next, attach the pipe standoff to the pipe with pipe straps. When inserting the pipe straps, be sure to place the straps between the pipe and cable, not on top of the cable. If the pipes are smaller than 1 1/2 inch in diameter, a small pipe adapter is required. Next, score the outer insulation 7 inches from the end of the cable. Carefully cut the outer jacket from the center to the end of the heating cable and remove the outer jacket from the cable. Be careful not to cut the metal braid. Move the braid back toward the overjacket. This will create a bulge. Separate the braid and create an opening. Now, while bending the heating cable, work the cable through the braid opening and pull it tight. When this is complete, score the inner insulation 6 inches from the end by cutting the inner jacket up from the center to the end of the heating cable. Then remove the inner jacket from the cable. Cut the excess material from between the bus wires. The wire preparation for self-regulating heating cable is now complete. Proceed to corresponding kit installation video to complete installation of the kit. For more information on any Chromalox product, please visit chromalox.com. This video will demonstrate how to This video covers the electrical termination of self-regulating cables using the Chromalox UPC Power Connection Kit. The Chromalox UPC Power Connection Kit provides the necessary terminations for all electrical connections. Each kit contains all materials required to make an above-insulation power connection for either self-regulating or constant wattage cables, including a junction box, pipe standoff, compression fitting, lock nut, silicon termination boot, O-ring, RTV, a black grommet for self-regulating cable, and an orange grommet for constant wattage cable. Ensure adequate space is available for installation based on the dimensions of the UPC kit. The following tools are needed for installation of the UPC Power Connection Kit. Before beginning the project, disconnect all power and make sure the installation is grounded in accordance with the National Electrical Code. Also, be sure to turn off the power before removing the lid of the box. When installing any Chromalox heat trace product, always utilize the proper personal protective equipment and be sure to comply with all applicable safety guidelines. Noted. With the cable properly installed on the pipe, begin the UPC power connection installation by taking the RTV and applying it liberally over the exposed matrix and leads. Then push the rubber boot over the heating cable. If you need help with the wire preparation, see the wire prep video for self-regulating U-Series kits on Chromalox.com. After the rubber boot is in place, strip each bus wire so that the black matrix material doesn't show above the end of the rubber boot. If the wire extends more than a 1/4 inch above the rubber boot, trim the ends so that only a 1/4 inch of exposed bus wire remains. Next, slide the compression fitting over the cable and place the grommet inside the pipe standoff. Ensure the termination boot is spaced a 1/2 inch from the ceiling grommet. You're now ready to place the junction box on the compression fitting. Place O-ring over the compression fitting threads first, and then insert the compression fitting threads through the larger hole in the bottom of the junction box. Tighten the lock nut until the junction box bottoms out against the lip of the compression fitting. Attach a 3/4 inch hub for incoming power, sold separately. Use a flathead screwdriver to release the terminal spring clamps by inserting it into the square hole on the terminal block. Electrical connections should be made per the following diagrams. Finally, once the lock nut is in place and the wires are secured to the terminals, put the cover on the box and secure the lid by fastening the screws. Installation is now complete. For more information on the UPC power connection kit or any other Chromalox product, visit www.chromalox.com. This video covers the electrical termination, splice, or tee of self-regulating cables using the Chromalox UMC multiple power connection, splice, and tee kit, which contains all materials required to terminate, splice, or tee multiple cables. These materials include a junction box, compression fitting, lock nut, silicone termination boots, pipe standoff, RTV, O-ring, black self-regulating cable grommet, orange constant wattage cable grommet, jumper, brass lock nut, and conduit plug. Ensure adequate space is available for installation based on the dimensions of the UMC kit. The following tools are needed for installation of the UMC splice and tee kit. When installing any Chromalox heat trace product, always utilize the proper personal protective equipment and be sure to comply with all applicable safety guidelines. Before beginning the project, disconnect all power and make sure the installation is grounded in accordance with the National Electrical Code. Also, be sure to turn off the power before removing the lid. Adequate controls and safety devices should always be installed with any electric heating equipment. Now let's get started. The first step in the project is prepping the wire. If you need help with the wire preparation, see the wire prep video for self-regulating U-Series kits on Chromalox.com. Once the wires are prepped, begin the UMC power connection kit installation by taking the RTB and applying it liberally over the exposed matrix and leads. Then push the rubber boot over the heating cable. Trim lead ends as needed. Next, slide the compression fitting over the cable and place the grommet inside the pipe standoff with the termination boot spaced 1/2 inch from the ceiling grommet. Tighten the compression fitting until it bottoms out against the pipe standoff. You're now ready to assemble the junction box to the compression fitting. Place the O-ring over the compression fitting threads first, and then insert the compression fitting threads through the larger hole in the bottom of the junction box, tightening the lock nut until the junction box bottoms out against the lip of the compression fitting. Then attach a 3/4 inch conduit hub, sold separately. Use a flathead screwdriver as a T kit or a power connection kit for multiple cables. Be sure to wire your kit appropriately per the following diagrams. Finally, attach the junction box cover and tightly fasten screws to the seal enclosure. The installation is complete. For more information on the UPC power connection kit or any other Chromalox product,
Any questions on the video?
Bhaskar, any questions on the video? Nothing.
It was pretty much clear. The same thing actually I have demonstrated on the slides. So
Since the video is much more clearer,
Yeah.
so probably like we can skip those slides and move on to the next one.
yeah.
It's okay with you, right?
Yes.
Okay, in your case, we are giving the junction box cum thermostat arrangement. So in the videos, that particular arrangement was not shown. So it is just a matter of the electrical connection. Otherwise, the rest of the procedure remains same. It is just how you connect the wirings that will just differ minorly. Otherwise, everything is same. The end seal. In your case, I don't have the installation manual for the end seal what we are supplying to you, but that's the reason I've given just right now for demonstration purpose. I'm showing you some another end seal, which is of the different I can say model number. In your case, we are supplying the rubber grommets, but the preparation of the end seal remains same, whether it is rubber grommet or whether it is RTES end seal. In this first section, you have to slide and you have to remove. Hello.
Yes, yes.
Okay, you can skip the step number 1, which is shown here because it is applicable only for this end seal. You can consider from the step number 2, score the outer jacket 1 inch from the one end of the heating cable, remove the jacket to expose the bread, unveil the trim the bread flush with the outer jacket, pull any strands of the bread back towards the outer jacket. This process has to be done, and once this is done, you have to do the V cut over there, and you will be having a rubber boot kind of a grommet or the end seal. You have to fill it with the RTV sealant, and you have to just press it on top of that. So that's it. Very simple. Any question on this?
Nothing.
The positioning of the sensors.
Excuse me.
Yes, sir.
Junction processor EHT, right? Which one is this one?
Rating, right?
Certified for the hazardous area, right?
Yeah.
Yes. This is about the sensor location or where the sensors has to be located. It should be 90-degree displacement from the heating cable. You can see here at the bottom portion. We can give it for the gas application also, that we have to prepare separately for you.
Okay.
This is the last slide of the presentation. Once the installation is done, or rather during the installation, there are certain things has to be recorded and the report has to be prepared. The important part is about the recording the drum length or the circuit length, the drum number. Those records has to be prepared, and the measure has to be done at these 4 intervals. First step of the first time measure has to be done on the drum. Second, it has to be done after the heating cable is installed on the pipeline. Third, after installing the thermal insulation on the heating cable, and fourth, before commissioning. So these 4 stages of the mega values has to be recorded, and the report has to be prepared. Right now, I don't have any format with me to display to you, but I will take it from the construction team and I will share with you. So that's it about installation presentation. Any questions?
Presentation with us.
Sorry, can you repeat that, please?
This presentation can you share with us?
Oh, definitely.
Yes, sure,
Yeah, we will do that.
Rather, we have requested Amar to record it, right?
Yeah,
So
the recording link also will be given to you, and we also share the PDF copy of this presentation to you.
Okay. Any questions? Oh, that video also. Video YouTube link link already that I will send you, no problem.
I think we already given the link also to you. No? In fact, in that presentation, the link will be there. அது யூடியூப்ல போய் தேடினாலே கிடைக்காது. So we'll send the link to you anyway.
Okay.
So I hope everything is clear. Presentation means like
Now, by today night or tomorrow, we will share the gas line with each sizes separately, with identifying the isometric line number and all, and the oil line separately. And we will share you the cross section of the oil line where the existing steam tracing line is there, so that you can propose where you have to put the tracing taper.
Sure.
Okay.
Drum length
Yeah.
we have.
Once we receive the drum length, we will give the drum length, then you will give the which schedule you have to cut and use for the each isometric.
Okay.
Because now Doha we are going to start immediately. Already that line is new gas line. So no commissioning done, nothing is there. So we can start immediately. So we will share immediately Doha, the pipeline length and the cable drum, whatever size we received. So please advise which drum you have to use. Accordingly, we will use it.
Okay.
Great, fine. So is there anything else to be discussed here, or we can close off the meeting for the day?
You know, your supervision people are available here, right? They can come for a site visit and first startup time they can be there, right?
And GEC supervision team will be there, they'll be guiding you how it has to be done. And they have experience in doing that, so.
Okay.
Yeah,
But
yes.
they are familiar with your system, right?
Yes, heating cables are pretty similar, so they are comfortable in doing that.
No, because previously they are familiar with the Thermon. That's why I'm asking you. Your Chromalox, they are familiar, right?
Yes, it is. Yeah, I mean,
Yes, sir, all manufacturers have the similar construction of the heating cable, so it is not a challenge for, if they have done Thermon, they can do this.
Very similar to each other.
Okay.
Okay.
மெகர்லாம் பண்ணிட்டீங்களா கேபிள் வந்ததுக்கெல்லாம் இப்போ பண்ண வேண்டியதானே ஏன் பண்ணல பண்ணிட்டு ரிப்போர்ட் அனுப்பி விடுங்க ஓகே
Fine, all right. Thank you very much to everyone over there for listening to this or being patient in listening to the presentation.
No problem. Very nice. Okay. Please share the presentation with us.
Sure,
Okay.
definitely we will do that. Yes.
Thank you, sir. Have a nice evening.
Thank you.
Very much. Yeah. Bye-bye.
Bye.
Okay.
And
Bye.
having any queries, just feel free to reach us. We'll be happy to clarify those queries.
Yeah, sure.
Okay.
Perfect. Thank you very much. Have a good night. Yeah. Bye.
Take care.